My group and I chose to focus our project on the Chicago Police Data Project, which is actually an initiative by the Invisible Institute. The focus of this data is to hold public institutions accountable. So, in this particular instance, we were talking about cases of police brutality in the Chicagoland area being reported and actually documented in this form of data. Now, we were given access to this data in our data science class, and we spent a quarter playing around with it, but we thought that the machine learning applications of this data set would be super interesting, and we wanted to build some predictive models from what we learned in class to analyze some of this data. Now, just as a quick overview of the data we were given, we had a lot of data pertaining to the actual police information, so the officer and specific details about the IDs and where these officers patrol, what kind of officers they are in terms of race and rank and all that sort of thing. And then, of course, this was combined with the actual reports that were filed against these officers. So in this particular instance, we have the TRR, which stands for Tactical Response Report, which actually documents the report made by the citizen against a police officer when the case of brutality occurred. So where it occurred, what kind of brutality occurred, what the conditions were, etc. And of course, we have many more details in this exact table. Now, one of the things that we thought was important was to combine this data with some of the other data that was available publicly. And so we were interested in the relationship between the socioeconomic status of some of these neighborhoods and the brutality rates that we were given and brutality information that we were given from the CPDB data. So we pulled data from online. This was publicly available, combined it actually with a lot of the data that was provided in the reports. And we wanted to build some models that connected the two, like in specific different socioeconomic groups in Chicago, what was the breakdown of brutality rates, and we could predict in the future going forward what we would expect to see. Also, we were interested in like understanding the relationships between certain attributes of these officers, so gender, sometimes the subject rank, the subject gender, the officer rank, and other details, but also what the likelihood or whether a response would be filed for a specific case of brutality based on these factors. And then finally, we're interested in tying the crime rates in a predictive model to the actual brutality that we observed. And this goes hand in hand a little bit with the socioeconomic status, but we were interested in breaking this down and seeing if we could notice differences here. Now, as part of this pre-processing, what we really had to do was use a tool called Trifecta that allowed us to join different tables into one and combine attributes that we thought were necessary in our predictive models. So for example, this is an unfiltered model, uncombined model. So this is a lot of the raw data that we were looking at beforehand, a lot of unnecessary details. And this is an example of a completed model through Trifecta that helped us pre-process. So here we've tied together the income and brutality for certain areas. So here we have different parts of Chicago and then their incomes and their brutality counts. Now, in combining these tables is super helpful because we were then able to take these combined condensed tables and create predictive models with them.
The question I worked on was to predict the brutality level or the case of police brutality given details of a case and the officer there, and in which beat he's in. We combined two databases here to do this prediction, and in doing so, we found that a lot of the data we had wasn't encoded as in it wasn't numerical. So I'd run a label encoder using sklearn library to be able to encode all values of the data given. From that, we given encoding of all values, we tried to predict the action level, as any action level greater than 4 was a case of police brutality and less than equal to 4 was not. So we were not doing the brutality label as that data was kind of inferred from it. So as long as we can predict something that's given, we were able to do something that's inferred. Action level and action category are the same in terms of wording. We used a decision tree classifier initially and we got an accuracy of 91%, but this accuracy was flawed as we'd used examples of resistance type, action, and resistance level. We removed resistance type as well as action as there were obvious classifiers as to how severe the action would be and making our model a little more efficient in prediction. We found that since these features are actually very important, the decision tree classifier's classification dropped severely to a 68.29%. And we found that the feature importance of all the classes so far, and the most important features was resistance level, which was important for our classification, and we got good information about it. Further, we used a random forest classifier, in which we used about 100 decision trees, and majority vote of this decision trees was used to classify a particular example, and we got a good 80% accuracy, which worked well, and a very similar feature importance level. To further work on it, we use a multi-layer perceptron model and saw that it failed severely. And we believe that a random forest classifier would work best with this data to predict action level, which would help us infer the brutality level of the brutality category of a certain case.
We attempt to build two predictive models, one targeting the hardship index and another one targeting the police brutality rates of the 77 Chicago community areas. We will be using our socioeconomic data for training. Based on the fact that we know there is a close relationship between the hardship index and socioeconomic data, we hope that by using a linear regression model with the right tuned weights, we can predict the hardship index based on the attributes that define socioeconomic data. On the other hand, we do not know of any relationship that should exist between the socioeconomic factors of a community and the police brutality rate. Therefore, we expect that even with well-tuned weights, the linear regression model for predicting police brutality rates should perform poorly. As you can see here, we do some data processing, some data splitting, and make a few plots to see the correlation between our target values and our data. As it can be seen, there appears to be some linear relationship between the hardship index and the socioeconomic factors, as opposed to the brutality rates and the others. After training our model and scoring it, we see, just as we expected, that there is a good score for the model that predicts the hardship index and a very poor score for the model that predicts brutality rates. Therefore, we understand that because the brutality rates are not closely related to socioeconomic factors, even with the well-tuned weights, the model performed badly. On the other hand, with like excellent weights that are tuned here, we can see that our model is very well able to predict the hardship index given socioeconomic factors.
Problem, we chose to classify whether a beat area was brutal or not. We did this using the scikit-learn library and specifically the k-nearest neighbors classification method. The cool thing about this specific problem was that we got the opportunity to actually do classification rather than a linear regression predictor. As you can see here, we called in the k-nearest neighbors classification object, and then using cross-validation, we decided how to break down the data set to really use it as a learning data set and a testing data set. We also decided to test using folds, specifically 10 folds. And as you can see here, using the folding method and 10 iterations or 10 folds, it converged to 100% accuracy. And using our cross-validation method, we got 97.6% accuracy. So pretty impressive accuracy. However, next steps, I would say, for a project like this would definitely be to incorporate more source data, specifically features such as our brutality count and crime count, and see how the labels or how the classification holds up on that new data. But overall, the actual classification was quite accurate, and this was a pretty good model to run on.